Hi, today we're looking at AQA Functional Skills Maths Level 2. This is the November 2021 paper and we're going to start with the non-calculator section. Question 1. Here is a scatter diagram. Okay, so here's all our points. 4 of the points are labelled. Which one of these points is an outlier? Circle your answer. Okay, right. Well, the best thing to do with this, because we've got a scatter diagram, you might be able to see it straight away, but the best thing is to try and draw your line of best fit. You're nearly always going to need to draw a line of best fit when you've got a scatter diagram. So we want to look at, well, what's the overall sort of data doing, or where are the points going in what direction? Well, we've got 3 points here. We've got 3 up here, 1 here, and then 1 sort of out of the way. Well, if we're trying to draw a straight line that follows the overall pattern, you'll see actually, it's difficult to draw a line that's going to pick everything up. And in fact, the best way of doing it would be something like this, which means the outlier is going to be that one over there. So an outlier means it's not following the same pattern as the others. So we would then circle C down here. Okay. Question 2. Work out, I'm going to put my commas in here, so we count back 1, 2, 3, and the same one is 1, 2, 3. So we've got 942,795 minus 350,823. So let's write this out. 942,795 minus 350,823. Well, let's start off with the units. 5 minus 3 leaves 2. 9 minus 2 leaves 7. 7 minus 8, well, we can't take 8 away from 7 because 8's bigger than 7. So we're going to reduce that by 1 and pass the 1 over. So we've got 17 minus 8. If we count back 8, that takes us to 9. We'll bring the comma down here. 1 minus 0 is still 1. 4 minus 5, again, we can't take 5 away from 4 because 5 is bigger than 4. So we'll reduce that to an 8 and pass 1 across. So 14 minus 5 is 9, and 8 minus 3 is 5. So our answer, which we can write down on this line, is 591,972. Question 3. The frequency tree shows information about the colour of 44 items. One of the items is chosen at random. Okay, so we've got our 44 items here. These are the red ones, so 20 are red, and the blue ones, 24. So see, this still adds up to that 44. Work out the probability that the item is blue. Okay, well, and it also says give your answer as a fraction in its simplest form. So, well, we've got 44 in total. How many of them are blue? 24 of them are blue. Okay, that's fine. So that would get us 1 mark. But they want the answer in its simplest form. So we've got to look for common factors. So numbers that go into both of the numerator and the denominator, or the top and the bottom, without leaving a remainder. Well, they're both even. So let's divide both by 2. If it's an even number, 2 must go into it. So let's try 2 into 24. 2 into 2 goes once. 2 into 4 goes twice. So that's going to be 12 on the top. And what about 44 divided by 2? Well, 2 goes into 4 twice, and the same again. So this is simplified down to 12 over 22. Well, they're still even numbers, so 2 can go into them again. So let's divide them both by 2 again. 12 divided by 2, well, divided by 2 it's half. So half of 12 is 6. And half of 22, you could do it using the bus stop method, but I know that half of 22 is 11. And that's as far as I'm going to be able to go with that one. 6/11. Question 4. Work out 19% of 150. Right, so you could write 19 over 100 times 150 and do it that way. I'm not going to do that way. I'm going to say, well, 19%, it's very close to 20%. So I'm going to start off by saying, well, I want 20% to start off. But if you think, well, 19%, well, that's 20% minus 1%. Okay? And the reason I'm saying that is because I think I can work out 20% without too much trouble, and I think I can work out 1%. So let's see how we do that. Well, we're going to start off with something even simpler. We're going to say, well, 10% of 150. Well, if you want 10%, you're dividing by 10, you just take a 0 off. So that's going to be 15. So if we want 20%, well, 20 is double 10. So we want 15 times 2, or 15 plus 15. So 2 times 5 is 10. 2 times 1, or 1 times 2 is 2, plus another one is 3. So in other words, we doubled the 15 to get 30. So that's 20%, what we're after here. Now we want to know what 1% is. Well, I'm going to go back to this one. Well, I know that if 10% of 150 is 15, well, 1% of 150, well, this is dividing by 100, 1%. So when we're dividing by 10, we just crossed off the 0. Or if you like, what we really did was we had the decimal point and we moved it in here to make it 15.0, which is just 15. If we want 1% of 150, what we're doing is we're moving that decimal point twice, because this is saying divide by 100, so we've got 2 zeros, so move it twice. So that's actually going to give 1.5 if we move the decimal point there. Okay, so if we go back to this thing, we're saying we wanted 20% minus 1%. Well, this is going to be our 20%, it's going to be 30, and our 1% is 1.5. Right, so we want 30 minus 1.5. And I've lined up my units. But I've got nothing to take the 0.5 from, so I'm going to make that 30.0. Okay. So I want 0 minus 5. Well, I can't take 5 away from nothing. And we've got nothing to borrow or to take from over here. So we're going to go all the way over to the 3, reduce that to 2 and pass 1 over. Now it's over here that we need something to take the 5 from, so we're going to reduce the 10 to a 9 and pass 1 over. So we've got 10 minus 5 is 5, 9 minus 1 is 8, remember we've got the decimal point, 2 minus nothing is 2. So our answer there is 28.5. There's other ways of doing it. Try other ways as well. See which you prefer. I think this is a nice way to think of it. Okay, question 5. We've got 2 lines here. This is telling me that they're parallel. And we've got this line cutting through with an angle X, angle Y, and this angle we're told is 115 degrees. Work out the size of angle X and the size of angle Y. Right, well, I know that my opposite angles, if they're being split by 2 straight lines, the opposite angles are going to be the same. So this is also going to be 115 degrees. Okay. Now, there's different ways of working out what Y is, okay? So what I'm going to do, now some people might know some rules, there's some sort of GCSE rules that will help you get Y a bit quicker, but I'm not going to go with that. I'm going to say, look at it a bit more simply. I know that the angles on a straight line, so all the way round there, would be 180 degrees. angles in a straight line. So that means that this bit, this missing angle, is going to be 180 minus 115. So if we write this out, okay, we've got 0 minus 5. Well, we can't do that. So take 1 from the 8, that becomes 7, and now we've got 10 minus 5, which is 5. 7 minus 1 is 6, and 1 minus 1 is 0. So we've got that this angle is 65 degrees. Okay? And if that angle is 65 degrees, this one here, well then this angle down here also needs to be 65 degrees. And like we saw before, our opposite angles have to be the same. So that's going to be 65 degrees as well. So down here for our answer, we've got 115. They've already put the degrees for us. And for y, we've got 65 degrees. Question 6. Joe has a baby. She calls the baby Ella. 6a. The graph can be used to convert between grams and ounces. Okay, so we've got this graph here. Okay, so we've got grams up here, ounces along here, and this line is used to help us convert from one measurement to the other. Let's get the full question in. At birth, Ella weighed 3.5 kilograms. Did Ella weigh more than 8 pounds? Use 1 pound equals 16 ounces. You must show your working. Right, well, this is in kilograms. We've got a chart here to help us convert, but this is in grams. So the first thing I'm going to do is say, well, can we turn this into grams somehow? And I know that we've got 1,000 grams in 1 kilogram. So if we've got 3.5 kilograms, well, we want 3.5 times 1,000. So, well, we've got our sort of 3, let's put 3.5 back here. Multiplying by 1,000, we've got 3 zeros. So we're going to be making the number bigger. So we're going to be moving this decimal point 1, 2, 3 times for each zero. Then we're going to fill that in with zeros. So you should see that that's 3,500 grams. Now we can use our little conversion chart up there to convert 3,500 grams into ounces. So we get a ruler, we find 3,500 grams, and we draw a line straight across to where it meets the line. And then we're going to draw a line straight down to get the number of ounces. Okay, so that's coming out here. Now you'll see 120 to 130, but we've only got 1, 2, 3, 4, 5 squares here, but we've got a difference of 10, so this must be going up in twos. So 122, 124, 126, 128, 130. So this here is 124 ounces. Okay. Well, did Ella weigh more than 8 pounds? Well, we're told that 8 pound, or well, 1 pound is 16 ounces. So 8 pounds is going to be 8 times 16. So let's do this down here. So 6 times 8, we've got 8, 16, 24, 32, 40, 48. And 1 times 8 is 8, plus 4 is 12. So we've got 128, and that's going to be ounces. Did Ella weigh more than 8 pounds? Well, Ella weighed 124 pounds. That's less, weighed 124 ounces, which is less than 128 ounces, which is equal to £8. So did Ella weigh more than £8? No. Okay, so it's good to think of how much have you got, how much do you need. So it's the 128 that we're comparing. That's what we're trying to look at, and it's less than that, so she doesn't weigh more than £8. (6b). Here are the birth weights of 7 other babies born on the same day as Ella. Joe's mum says Ella's weight of 3.5 kilograms is more than the average weight of the other 7 babies. Joe says it depends on which type of average you use. Show that Joe is correct. Right, so what we're trying to see is we want a calculation that's going to show us that Ella's weight, basically that the average is less than 3.5 kilograms, and we want another calculation that's going to show the average is more than 3.5 kilograms. How can you have both? Well, there's more than one average. Okay, so let's start off by working out the median. Okay, so I can put this median. Well, the median is the middle number. Okay, these are already sorted in increasing order, so we can cross off the smallest and largest, next and next, and that, and we're left with 3.6 kilograms. Okay, so that's showing us that Ella's weight of 3.5 kilograms is less than the average. We want a calculation that's going to show us that it's more than. Well, what other averages have we got? Well, we got the mode as well. The mode is the value that occurs the most. Well, 4 occurs the most times here. We've got 3 4s. We've only got 1 of each of these values. So the mode is 4 kilograms. But that's still showing that Ella's weight is less than the average. We want an average calculation to be less than Ella's weight. Well, the only other average we've got left is the mean. And the mean equals the total divided by the frequency. So if we want the total, we want 2.3, 2.5, 2.7, 3.6, and then 4, 4, 4, and we can put point zeros on here. So let's add these all up. Well, I'm going to add the 3 and the 7 together first of all, because I know that makes 3 and 7 is 10, plus 5 is 15, plus 6 is 21. So 1 carries 2. And bring that decimal point down. 2 plus 2 is 4, plus 2 is 6, plus 3 is 9, plus 4 is 13, plus 4 is 17, plus another 4 is 21, plus 2 is 23. Okay, so our total weight is 23.1 kilograms. So what we want is 23.1 divided by the frequency, which is 7. So let's do that with the bus stop method. Well, 7 doesn't go into 2. What about 7 into 23? Well, 7, 14, 21. So it goes 3 times. And then 22, 23. So that's remainder 2. What about 7 into 21? 7, 14, 21. That's 3 times. So we've got our mean is equal to 3.3 kilograms. Okay, so show that Joe is correct. Well, we can say mean is 3.3 kilograms, which is less than 3.5 kilograms. And we can put median, or you could do the mode. The median was 3.6 kilograms, which is greater than 3.5 kilograms. So she's right, it does depend on which type of average you use. C. Joe sees this special offer on a pack of nappies. We've got 1/3 off usual price. nappies. Pack of 25, usual price £6.75p. Joe normally buys nappies that cost 21p each. How much will Joe save per nappy by buying this pack? You must show you're working. Right, well, a couple of things we've got to do. First of all, we want to work out how much these nappies cost, because it's a third off of the usual price. Well, let's work out what a third of the usual price is. So a third of £6.75. Well, what's that saying is 6.75 divided by 3. So if we do this with the bus stop method, so how many times does 3 go into 6? Or 3, 6. It's twice. Keep the decimal point there. What about 3's into 7? 3, 6, still twice, but with 1 left over. And 3's into 15. 3, 6, 9, 12, 15. That's 5. So that's 1/3, and that's off the usual price. So if we want to find out how much the price is after the discount, it's going to be £6.75 minus £2.25. 5 minus 5 is 0. 7 minus 2 is 5. Decimal point. 6 minus 2 is 4. So it's going to be £4.50. That's for 25 nappies. Okay, so we want to know how much Joe will save per nappy. So really what we wanted to do is we want to save £4.50 divided by 25. Okay, looks a bit tricky this, so but we can still do it using the bus stop method. Okay, might seem a bit strange, but I'm going to do it this way. So we'll put our £4.50 in there, and we've got 25 on the outside. Okay, so well, does 25 go into 4? Well, no, it doesn't. So we've still got our 4 to carry over. What about 25 into 45? Well, 25 goes into 45 because it's less than that. What about, well, 2 25s would be 50. Would be too much. So 25 goes into 45 once. How much is left over? Well, that's going to be 45 minus 25. 5 minus 5 is 0. 4 minus 2 is 20. So we're going to have 20 left over. So that's 200. Okay. Now that might seem a bit of a strange one to do. How many 25s go into 200? Or 200 divided by 25. But what I'm going to do is I'm going to add them up. So I'm going to say, well, we've got 25 would be 1. What would 2 25s be? Well, 25 plus 25, 5 and 5 is 10. 2 and 2 is 4, plus 1 is 50. So 50 would be 2. So 25, 2 lots of 25 would be 50. What about if we double that? Well, 100 would be 4. Now we wanted to know how many 25s go into 200. Well, if we know 4 25s go into 100, 200 is double that. So for 200, it's going to be double 4, which is 8. Okay, you might want to go through that slowly just so you understand exactly what we're doing. We're trying to divide £4.50 by 25. So we can't do it into the 4, so we do it into the 45. When we do that, we get the 1, and we're left with 200. So saying how many times does 25 go into 200? We worked out it goes in 8 times. So this 0.18 is actually 18p per nappy. That's how much it costs with the offer. How much will Joe save? Well, that's going to be 21p minus 18p. Depending on how you want to do that, I would just count up from 18. 19, 20, 21. So it's going to be a 3p saving per nappy. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. The probability of an event happening is 3/5. Circle the probability of the event not happening. Well, probabilities always need to add up to 1. So the probability of it not happening would be 1 minus 3/5. Well, if you think of 1 is all of it. And we're working in fifths, so 1 would be like 5/5. So we want 5/5 minus 3/5. Well, we're dealing in fifths, so that's going to stay the same. So it's just 5 minus 3, which is 2. So that's my answer. Question 2. X equals 5, y equals minus 3.2. Work out the value of x plus y squared. So let's put the values in. So x becomes 5, and y squared, well, y is minus 3.2, and squared means times itself. So minus 3.2. So we've got that sort of calculation. This is really important where you put the minus, okay? Because we've got minus 3.2 times minus 3.2. Well, if we put that in our calculators, 3.2 minus, yeah, you can see the minus sign, times 3.2 minus, we get 10.24, and there's no minus. Because a minus times a minus is a positive number. So this is equal to 5 plus, remember those minuses have gone, 10.24. Okay. If you just did 3.2 times 3.2 and then put the minus in front, you're going to get a different answer. Okay, so remember the minus is the y bit. So you've got to have a minus times a minus. Right, so now we just need to add on 5. And we get 15.24. Question 3. Well, we've got some coordinates here. We've got the point A marked on there. We've got north going up here. Let's see what the actual question is. Okay, A is the point 1, 2. That's what they've marked on the grid. B is the point 3 squares west of A and 5 squares south of A. Work out the coordinates of B. Right. Let's go up to our compass first of all and fill in the other points. I always remember for north, east, south and west, never eat shredded wheat. Yeah. Or you might remember that south is the opposite of north, east on the right, west on the left. However you want to remember it, this is what we need to find out. And remember, B is the point 3 squares west of A. So we're going to go 1, 2, 3 to over here. But then it's 5 squares south of A. So 1, because south is down, so 1, 2, 3, 4, 5. So it's going to be down there, B. They want us to work out the coordinates. Well, the x coordinate is the one going across. Well, that's going to be minus 2. And the y coordinate is the up and down one, so it's going to be minus 3. And you can put that in the answer box right down at the bottom. So that was minus 2, minus 3. Question 4. In the boxes, write the number that is 3 more than minus 8. Or 3 more than minus 8, so that's minus 8 plus 3. So 8 minus. Maybe use your minus to get that in there. And we'll add on 3. We've still got the minus, so it's minus 5. We want 4 less than minus 2. So that's minus 2, 4 less than it, so we're taking 4 off. So 2. We need to put the minus on afterwards. It doesn't work. If you do minus 2, it doesn't like it. So you need the 2 and then put the minus in. So minus 2, minus 4. And we've still got the minus. It's minus 6. Okay, you can do this on a number line and work it out, but you've got your calculator, so you might as well use that. Halfway between minus 7 and 5. This is where a number line could be helpful. You could draw it out. Minus 7, 5. Put in all your values. Minus 6, minus 5. And work out where halfway is. Or, if you want halfway, you can say, well, add them together. So minus 7 plus 5. And then divide it all by 2. So 7 minus plus 5 minus 2 divided by 2, we get minus 1. Question 5. Write the ratio 144 to 90 in its simplest form. So this is like simplifying fractions. You're looking for common factors, so a number that goes into both of these without leaving any remainder. So I'm not going to complicate it, I'm just going to say they're both even numbers, so I'm going to divide both by 2. And I've got my calculator to help. So 144 divided by 2 is 72. And 90 divided by 2 is 45. Right, this is where you can then use your calculator to try and work out, well, what other numbers might go into both of these. Now, I know that if you add up the digits and add up to 9, then the number's divisible by 9. So I can see 7 plus 2 is 9, and 4 plus 5 is 9. So I must be able to divide both of these by 9. So 72 divided by 9 is 8. And 45 divided by 9, sorry about that, is 5. So that's our answer. Let's say, if you didn't spot this, then you could just keep trying. You could try numbers, well, they're not both even, so they're not even, but you could try maybe divide both by 3. Yeah, 72, you can divide it by 3, and 45 divided by 3. So that would take you down to, what was that? That would be 24 to 15. And then you could try again. Well, what about if I divide both by 3 again? So 24 divided by 3 is 8. So we're doing it again. And 15 divided by 3 is 5. So you still get the same answer. But if there's any shortcuts or things you can spot, just saves you a little bit of time. Question 6. Here is an isosceles triangle. Work out the size of angle X. Well, an isosceles triangle, that has 2 sides which are the same length. They've marked them here for me. As well as having 2 sides the same length, it has 2 angles which are the same. So if this is 42 degrees, this must also be 42 degrees. Okay. Now, I know the total angles in a triangle or total degrees in a triangle might be better, is 180 degrees. So if we add these up, take them away from 180, what's left must be X. So 42 plus 42 is 84 degrees. So then we can do 180 minus 84, which gives us 96 degrees. And we can put that down here. Okay, question 7. Energy. Jim's house has gas central heating. The charges for the gas Jim uses are shown in the table. So the cost per unit of gas in kilowatt hours, don't worry if you don't know what this stands for, it's just some unit, is 2.92p. The standing charge per day, so you have to pay this regardless of how much gas you use, is 39.6p. In November, Jim uses 1,976 kilowatt hours of gas. Use approximations to estimate Jim's November gas payment. Give your answer in pounds. Right, approximations. So straight away I'm going to say, well, 2.92p, that's about 3p. And 39.6p, that's about 40p. What about 1,976 kilowatt hours of gas? Well, that's very close to 2,000 kilowatt hours of gas. Right, so we've done the approximations. Now we can do our calculations. Right, we wanted to estimate his November gas payment. Well, it's 3p per unit of gas in kilowatt hours, and he uses 2,000 kilowatt hours. So we want 3 times 2,000. And I don't need to use my calculator for this. 3 times 2 is 6, and then just put the zeros on. And that is in p, that's in pence. Okay. Then as well as that, we've got to put in the standing charge per day, which is 40p. Okay. So this is the, that's for here. So we want 40p per day. Well, we're in November. How many days in November? If you remember the little rhyme, it's 30 days have November, April, June. Oh no, 30 days have September, April, June and November. So it's going to be 40 times 30. Again, we don't need the calculator. 4 times 3 is 12. Put 2 zeros on the end. Okay, so if we want the total gas payment, we want 6,000 plus 1,200. Oh, you're welcome to use your calculator here if you want to. 6,000 plus 1,200. 7,200. Remember, that's still in p. So if we want to turn it into pounds, we're going to need to divide it by 100. Or just take off 2 zeros. And we're going to get £72. Jim's 7b. Jim's current gas company produces 43% of their gas from green sources. He sees this pie chart for another gas company, Mix Gas. Okay, so we've got the gas source. We've got 198 degrees of the pie chart is for non-green, and the rest is for green. Jim wants to use a company with a greater proportion of gas from green sources. Should Jim change to mixed gas? Okay, well, we want to know sort of how much of this is green. Well, I know that in a circle, total degrees, so all the way around, is 360 degrees. So the bit just for green is going to be 360 minus 198 degrees. So 360 minus 198, that gives me 162 degrees. But they're talking about proportions. So proportion, we want percentages. Okay, so what we want is we want to know, well, 162 out of 360, if we multiply that by 100, that's going to give me the percentage. And then I can compare that to the 43% they've given us. So 162 divided by 360 times 100, 45%. So should Jim change to mixed gas? Well, mixed gas has got 45%. His current company has 43%. So we can say 45 is greater than 43. So yes. He should change. (7c). Jim is thinking of buying solar panels. The price of these panels has decreased by 27% since 2016. Jim would need to pay £4,803.40 for the panels now. How much would the panels have cost in 2016? These questions often cause problems, okay? Because people are going to, what a lot of people will do is say, well, I need to work out what 27% is and add it back on. That's not going to give you the right answer. Because the original price, the starting price would have been 100%. It's decreased by 27%. So if you think of 100 minus 27, what you're left with is 73%. So in fact, £4,803.40 represents 73% of the original price. So if we want to get back to 100, well, what we can do is say, well, let's work out what 1% would be first of all. So let's do £4,803.40. Divide it by 73. It's going to tell us what 1% is. So 4803.40 divided by 73. So 65.8. So that's for 1%. So if we want 100%, well, we want 65.8 times 100. And we get £6,580, which we can put down there. Question 8. Dog. Ben has a dog called Pluto. Ben takes Pluto for a walk. They walk 4 laps of a sports track. The sports track is the shape of 2 semicircles joined by 2 straight sections. So a semicircle there, and actually I'm going to draw on. There you go. So we've got semicircle, semicircle, and 2 straight sections. And we're told that this distance is 30 metres, this distance is 120 metres. Ben has a target to walk 5,000 metres each day. What percentage of his daily target has Ben completed on this walk? Okay, so what we need to do is we need to work out what this distance is, and then we're going to multiply it by 4 because he did it 4 times. Well, these bits are going to be nice and easy because if that's 120 metres down there, well, this is going to be 120 metres as well. What we need to work out is this semicircle here. Well, in fact, it's a semicircle, but if you think we've got a semicircle and another semicircle, that just makes 1 circle. Okay, so we want the distance around the outside, or the circumference. Well, the circumference is equal to, you can think of it as 2 pi r, where r is the radius, or you can think of it as pi d, where d is the diameter. And in fact, that's what we've got here. Our diameter is 30 metres. Okay. So our circumference is equal to pi, which is 3.14, times our diameter, which is 30. So 3.14 times 30, we've got 94.2 metres. Okay, that's all the way round. So what we've got to do with that, we've got 94.2 metres, we've got to add on 120 metres up there, and we've got to add on another 120 metres at the bottom. Okay. Now if you're thinking, oh, don't we need this twice because we've got that and that, well, remember that's a semicircle and that's another semicircle. So actually, if you want to know the distance of that, you could divide 94.2 by 2. So in other words, what we're saying is that is 47.1 metres, and that's another 47.1 metres. But we're just adding them together. Yeah, we don't need to divide it by 2. So we've got that plus that is 94.2 metres. Add 120, add another 120. and we get 334.2 metres. Right, now we don't want to forget that they walk 4 laps. So we want 4 times 334.2, which is 1,336.8 metres. Now we want to know what percentage of his daily target he's completed. Well, he's done 1,336.8 metres out of a target of 5,000. We want to turn it into a percentage, so we're then going to multiply it by 100. So we've still got the answer in our calculator. Divide it by 5,000, times it by 100, and we get 26.736. Oh, not metres, percent. We could round it. They haven't asked us to round it, so I would probably just leave it like that in the answer box. 26.736. But you could write it as 26.7 if you wanted, rounding it to 1 decimal place. Okay. 8b. Pluto needs to eat 420 grams of food each day in the ratio wet food to dry food 2:5. So in other words, if he eats 2 grams of wet food, he needs to eat 5 grams of dry food. Ben buys a 12 kilogram bag of dry food. How many days of dry food does the bag provide? Right, so let's see. So this, we've got a ratio here. So let's draw a ratio table. So we've got wet, dry, and we're going to have a total column. So the ratio of wet to dry is 2:5. So if we only had 2 wet and 5 dry, we'd have 7 altogether. Well, we've actually got 12 kilograms of dry food. Okay, so we want to know, well, how are we getting from 5 up to 12? Or in other words, what's 12 divided by 5? Let's go backwards. Or the inverse operation. So 12 divided by 5 is 2.4. So we're saying we're multiplying that by 2.4. Well, we want to work out what the total amount of food is, so we need to multiply the total by 2.4. Because if we can work out what the total amount of food is that he gets from these bags, well, we know how much he eats a day, and we can then do a comparison there. So we've still got our 2.4, we'll multiply that by 7. So that's telling us, in fact, let's put the units in, this is kilograms. Okay, so we're saying that a 12 kilogram bag of dry food, actually when you take into account how much wet food he needs, is going to be a total of 16.8 kilograms of food, okay, that we've got for the dog. Okay, so we've got the amount of food he eats in grams. So I want to turn this from kilograms into grams, so I'm going to multiply that by 1,000. We get 16,800 grams. So that's the total amount of food we've got. He eats 420 grams a day. So we're going to do the total, 16,800, divided by 420. This should tell me how many days it's going to last. And we've got 40 days, which we can then put down here. Okay, oh, I was going to try and fit it all on. Can't quite do that, that's right. 8C. In his garden, Ben has a rectangular fenced area for Pluto. The fenced area measures 2.4 metres by 2.25 metres. Ben builds a kennel for Pluto which covers 1/6 of the fenced area. Here is a sketch of the kennel. So we've got 0.27 metres this way, and then we've got the length. The base of the kennel is a rectangle. Work out the length of the kennel. Okay, right, so let's think of this. He's got a rectangular fenced area. Here's our rectangle. Now we're saying it's 2.4 metres by 2.25 metres. He builds a kennel which covers 1/6 of the fenced area. So let's kind of like split this up into 6. So this would be the kennel area. Okay. Now, we know one length, or we know the width. We need to find out the length. So what we can do is work out what the total area of this is. Then if we take 1/6 of it, it's going to tell us just the floor space of the kennel. And then we can use this measurement to work out the length. So we're going to start off by saying the total area is going to be 2.4 times 2.25. Okay, this is the total area of the fenced area, or the total fenced area. 2.4 times 2.25, which gives us 5.4 metres squared. We want 1/6 of that. So 1/6 of, or times 5.4, or you can think of that as 5.4 divided by 6. And we get 0.9. That's 0.9 metres squared. Okay. Now let's just draw this so we can see that's our rectangle or rectangular base of that kennel, and then you've got sort of like that. Yeah, something like that. And I'll make it more 3D. Okay. So we know that the area is the length times the width. Well, we know what the area of the kennel is now. It's 0.9. And we know the width is 0.72. So the length times 0.72 gives us 0.9. So we need to do a reverse calculation. We need to do the opposite of times. So what this is saying is, well, the length is going to be the area, the 0.9, divided by the 0.72. So 0.9 divided by the 0.72, make it 1.25 metres. Question 9, fundraising. A charity organises an annual sponsored swim. 9A. Ahmed swam 50 lengths of a pool that is 25 metres long. The swim took him 38 minutes. Ahmed says, my average speed was more than 0.7 metres per second. Is Ahmed correct? You must show your working. Okay, right, so let's start off by thinking, well, how far did he swim altogether? Okay, he swam 50 lengths, 25 metres long. So 50 times 25 is 1,250 metres. Okay, and how long did it take him? Well, it took him 38 minutes. Now he's talking about speed in metres per second. Well, we got this measurement in metres. We want to get this into seconds. So it's going to be 38 times 60, because there's 60 seconds in a minute. 38 times 60, 2,280 seconds, or secs. Right, so it might help you to draw this little triangle. You don't have to, but we've got speed, we've got time, we've got distance. Now, if you can remember that the distance is the speed that you're travelling at times the time you're travelling at that speed for. So in other words, if you travel at a speed of 50 miles an hour, for 1 hour, you're going to travel 50 miles. Now, we're trying to work out the speed, so not the distance. The distance, you multiply the speed and time together. If you want the speed, well then you want the distance divided by the time, because distance over time. So we're going to have speed is the distance, which is 1,250, divided by the time. Now it's important that they're the right units. Okay, so you've got to do this with meters and seconds. So if we do our 1250 1250 divided by 2,280, we get 0.548, and that's meters a second. Well, that's less than 0.7. So we can say 0.548 is less than 0.7. So, no. He's incorrect. (9b). Ahmed collected £35 for his swim and gave it to charity. 6/7 of this money was donated by taxpayers. Using gift aid, the charity claimed an extra 25p for every £1 donated by a taxpayer. How much money did the charity receive, including gift aid, from Ahmed's swim? Right, so he's got £35, but he's going to get some extra money for the gift aid. So the final answer should be something more than 35%. Well, we want to work out how much money was given by taxpayers, first of all. And we know it's 6/7 of the money. So we want 6 divided by 7 times 35. Oh, 6 divided by 7 times 35. And we get 29.999999, which we can round up to £30. This is the issue we get with a simple calculator I told you about before. If you get something like that, you can swap the order around instead. So if you want to put it as 35 times 6/7, you'll see that it simplifies the calculation, and then we get 30 without having to round. Okay, so that's an alternative. Right, so £30 was given by taxpayers. They can claim an extra 25p for every £1. Well, we've got £30, so it's going to be 30 lots of 25p. So 30 times 25, 750. And I deliberately put the p in there because it's easy to forget that. It's not in pounds, it's in pence. Well, 750p, if we want it in pounds, we divide it by 100. So that's £7.50. So the total money that the charity actually got, well, they got the £35 to start with, and then they get this extra £7.50 from gift aid. £7.50 plus the 35 gives us £42.50. I've added the 0 because it's money, so we've always got to have 2 decimal places. Question 9c. This year, 20 people completed the sponsored swim. The table shows information about the sponsor money collected. So 7 people collected between £0 and £10, 4 people collected between £10 and £20, 6 people collected between £20 and £30, 1 person collected between £30 and £40, and 2 people collected between £40 and £50. And we've got a total of 20 people, as it says up there. Okay. Last year, the mean amount collected per swimmer was £14.85. The charity organiser says this year's mean amount is more than £3 higher than last year's. Show your working to support this statement. Right, so we've got to work out the mean. Now, we've got group data here. So if you remember, for the mean, we want the total divided by the frequency. Well, in this case, to get the total, we haven't got amounts to add up because we know that they collected, like this first bracket, 7 people collected between 0 and £10, they could all have collected £1. They could all have collected £7. One of them could have collected £2 and the rest £6. We don't know. So what we do is we say, well, let's assume that they collected in the middle of this range. Okay, so that's like saying halfway. Okay, and the way that we do that is we take the two end points, so the 0 and the 10, add them together, so 0 plus 10, and divide them by 2. So we get a midpoint of 5. Yeah, so you can probably see, well, 5's halfway between 0 and 10. Same with 10 and 20. You could say, well, what's halfway between 10 and 20? Well, it's 15. But if you're not sure, again, do 10 plus 20, get your answer, then divide it by 2 to get 15. So let's do the same with these others. 20 plus 30, divided by 2, is 25. 30 plus 40, make sure you do equals first before divide 2, or you won't get the right answer. And in fact, I'll show you that. Look, if we're doing 40 plus 50, if I actually use a simple calculator, you're going to be all right. If you're doing a scientific calculator, you might not. We get 45. Okay, so there were 7 people with this range. Well, in fact, now we've got the midpoints, we can forget about those values. So we can say there were 7 people that collected £5. So the total that they got is going to be 7 times 5. And we're going to do this for each of them. Okay, so 7 times 5, that's £35. 4 times 15, that's £60. 6 times 25 is £150. 1 times 35, well, that's just 35. And 2 times 45, that's £90. So how much was collected in total? Well, it's going to be 35 plus 60 plus 150 plus 35 plus 90, which is £370. So we said our mean is the total divided by the frequency. Well, our total is 370. Our frequency is 20. So 370 divided by 20. We've got £18.50. This year's mean is more than £3 higher than last year's. Well, last year's was £14.85. So if we add 3 to that, we get £17.85. And yes, £18.50 is indeed more than £17.85. So that's shown that that's correct. Question 10. Conservatory. Molly is building a conservatory. 10A. Here is a plan view of the conservatory, so looking straight down onto that conservatory. Let's pick this up. Okay. And we can see it's 3.4 metres this way, 4.5 metres down, 4 metres across, 3 metres up, and we haven't got this measurement on the diagonal there. The conservatory floor will be made of concrete. The concrete floor will be 0.1 metres deep. What volume of concrete will Molly need for the floor? Right, so for the volume, normally if it's a cuboid, we'd do the length times the width times the height. But because it's not a cuboid, we've got this funny shape, this sort of funny cross section. But what we can do is show we have got depth to this. Just so that you can see this is a 3-dimensional shape. And it's this measurement which is our 0.1 metre deep. Well, if we can work out the area of this, then we can multiply it by the depth. So it's going to be the area times the depth. Right, we've just got to work out the area of this shape. Well, it's not totally straightforward unless we split it up into shapes that we know. And what I'm going to do is draw a line straight across here, because if I do that, I've now got a rectangle down here, and I know the area of this rectangle is going to be the length times the width, which is a nice straightforward 12 meters squared. Now, what about this shape up here? You could cut it off and work out a triangle and have another rectangle, or you could say, well, actually, this is a trapezium. Now remember, a trapezium is a four-sided shape, 1, 2, 3, 4, with one pair of parallel sides, top and bottom. And the area of a trapezium is a half of A plus B, where A and B are the parallel sides, and then you multiply it by h, which is the height. Okay, well, we've got A and B, so it's going to be a half of, well, A is 3.4, and B is this measurement, which is going to be 4 meters. And h, well, h is just this height here. We haven't got that at the moment, but we do know the full height is 4.5 meters, and we know this bottom bit is 3 meters. So h is going to be 4.5, the full length, taking off that 3. So if we do 4.5 minus 3, we've got 1.5 meters. So now we just need to put that through here. And because we've got the half next to the brackets, I'm going to put my multiply in. But we need to work out what's inside the brackets first. So 3.4 plus 4 gives us 7.4. So we're going to have a half times 7.4 times 1.5. In fact, we can replace that so that we've got decimals through. We can replace the half with 0.5. So we're going to have 0.5 times 7.4 times 1.5, which gives us 5.55 meters squared. That's our area. Okay, now that's the area of the trapezium. Remember, we've got this area as well, so we can say the total area is going to be 5.55 plus a 12, which gives us 17.55 meters squared. Now, we said at the beginning that the volume is the area times the depth. We've got the area now. We already had the depth. So multiply them together. Get 1.755, and it's going to be meters cubed because it's volume. And they do say state the units of your answer as well. So that's going to go right down here at the bottom. 1.755 meters cubed. (10b). Molly has a scale drawing of the side elevation of the conservatory. The scale of the drawing is 3 to 50. So that means 3 centimetres on the drawing would be 50 centimetres in real life. The height of the conservatory on the scale drawing is 23.4 centimetres. Is the actual height of the conservatory less than 4 metres? Right, so let's think of this as like a proportional ratio table. So we've got the drawing measurements, and then we've got real life. And we're saying that 3 whatever, I said centimetres, but it doesn't have to be centimetres, it could be metres, but 3 whatever they are on the drawing are going to be 50 of them in real life. Okay, we're saying that actually on the drawing it's 23.4 centimetres. So we want to know how we're getting from 3 up to 23.4. So we do the opposite, we do 23.4 divided by 3. Which gives us 7.8. So that means we're having to multiply this by 7.8, so we're going to have to do the same to this one here. So 7.8 times 50 means that in real life it's going to be 390, and that's all in centimetres. I say it doesn't have to be, but because we're working with centimetres here, I'm going to put them in. Right, is the actual height of the conservatory less than 4 metres? Well, we're working in centimetres, so let's turn this into a centimetres. There's 100 centimetres in a metre, so 4 times 100, it'll be 400 centimetres. Well, 390 is less than 400, so yes, the actual height is less than 4 metres. And 10C. Molly wants to build a brick wall as part of the conservatory. It would take Molly 12 hours to build the wall by herself. Molly pays 2 builders to work with her to build the wall. Molly pays each builder £14.73 per hour. How much will Molly pay each builder for their work? Assume that Molly and the builders work at the same rate. Right, so 12 hours to build the wall by herself. If she's paying 2 builders to work with her, there's now 3 builders. So instead of 12 hours, it's going to be 12 hours divided by 3. So in other words, each of them is doing 4 hours work. Yeah. 4 for Molly, 4 for builder 1 and 4 for builder 2, which still adds up to 12 hours altogether. Okay. Each builder is paid £14.73. So how much will each builder get in total? Well, it's going to be 4 times £14.73. Which is £58.92. Now note, it would be very easy for them to have asked, how much is it going to cost Molly to get the work completed? In which case we'd have to double this because we've got 2 builders. But they have said, how much money will Molly pay each builder? So that's why we're just doing it for one of them. And that's the end of the paper. So hope you found it helpful. Please like the video, subscribe to the channel, make sure your notifications are turned on so you find out when I upload new videos. And I look forward to seeing you again soon. Thank you.